Hi everyone, I am Teacher Michelle and welcome to another episode of Unang Math. In this episode, I will be discussing this lesson about the mid-segment of a trapezoid. In our previous episode, we already studied the proportional segments between parallel lines. Okay, now, take a look at this figure. According to this, line L is parallel to line M and parallel to line N. So these three lines are parallel. Now, if we will remove these lines here on top and these lines below, then we now have a trapezoid. So this is a trapezoid. So in this episode, we will focus on the mid-segment of a trapezoid. So in this trapezoid, mid-segment is this straight line. Okay, how are we going to find the length or the measure of this mid-segment? Okay, let's give an example. If this is our trapezoid, and as indicated here, this is 12, this is 22. 2 and 3 are not the length of these segments. Rather, this is the ratio of these sides of this trapezoid. Okay, the mid-segment is this straight line. So how are we going to find the length of this mid-segment? There are two ways to do that. The first way is what we will use the concepts of parallel lines. So how is that? We are just going to draw a straight line that would be parallel to one side of our trapezoid. And in here, this is the straight line that's parallel to this side of this trapezoid. Okay, since these two lines are parallel, and as you can see, this line or this segment and this segment are also parallel. So we have here two pairs of opposite sides that are parallel. So this is a parallelogram. It's indicated here that this is 12. So it means this is also 12 and this is also 12. Okay, now, when we draw this straight line that's parallel to this side, we now have this triangle and this smaller triangle. These two triangles are similar figures. So, why similar figures? This is a common angle, and since these two lines are parallel lines, then it means these angles are corresponding angles. So, this is AA similarity. So, these two triangles are similar figures. Okay, we already know that from here to here, that's 12. To complete the length of this mid-segment, we have to find out what is the length of this segment. Okay, this segment is part of these triangles. Since these two triangles are similar figures, then we will be using the ratio of similarity. So, this would be 2 is to 2 plus 3, 5. So we have 2 is to 5, and that would be equal to the ratio of this length. Okay, let's call this x is to this length. Okay, from here to here, that's 22. From here to here, it's 12. So 22 minus 12, then it means this is 10. So we have here x is to 10. So if we're going to solve this one, then this is 5x is equal to 20. So it means x is 4. So this is 4. So 4 plus 12, then that means this mid-segment is equal to 16. Okay, moving on to our second way on how to find the length of the mid-segment of a trapezoid is using the concept of diagonal line. So we are going to draw a diagonal line. Okay, in this trapezoid, this is our diagonal line. So from this vertex to this vertex, So this is our diagonal line. You can also draw like this, from this point to this point. So this is also another diagonal line. But for this time, we will be using this diagonal line. Okay, when we draw this diagonal line, we now have this triangle, and we have here this smaller triangle. Okay, so this is 12. From here to here, it's 22. Again, 2 and 3 here are not the length of these segments. Rather, this is the ratio of the sides of these triangles. Okay, since these two triangles are similar figures, okay, if you're gonna ask why similar figures, again, this is a common angle. These lines are parallel lines, so it means these are corresponding angles, equal in measure. So this is also AA similarity. Okay, so first, we are going to find the length of this segment. So let's say this is X. Okay, since these two triangles are similar figures, then we will be using the ratio of similarity. So this is 2 is 2, 2 plus 3, that's going to be 5. So we have 2 is to 5, and this is equal to this length, which is X, is to this length, 22. So this is 5X is equal to, okay, 44. Okay, if we're going to simplify, we will be dividing both sides by 5. Then it means X is 44 over 5. So this length or this segment measures 44 over 5. Okay, now, to complete this mid-segment, we have to find the length or the measure of this segment. Okay, since this is the segment that we are going to focus, okay, now we are going to check this triangle. Okay, this is 2. From here to here is 3. Take note, this is the ratio. But if you're going to take a look at this triangle, it's upside down, or the triangle is tilted. Okay, that's why the ratio that we will be using here is 3 is to 5. So we have 3 is to 5. That's going to be equal to the ratio of this length. Okay, let's say this is y, is to this length. So we have y is to 12. Okay, simplify. So this is 5y is equal to 36. Dividing both numbers by 5 or both sides by 5, then it gives 36 over 5. So this length or segment is 36 over 5. Okay, and finally, to get the length of this mid-segment, we will add these two numbers. So 44 over 5 plus 36 over 5, then this is now equal to, we have here 80 over 5. So 80 divided by 5, that's equal to 16. So it means this mid-segment is 16. Okay, moving on, let's now answer these simple questions. Okay, our first question here is, in trapezoid ABCD, so ABCD, this is our trapezoid. Segment AD is parallel to segment EF, parallel to segment BC. And segment AH is parallel to segment DC. So segment AD, segment EF, BC are parallel lines. Okay, also, segment AH and segment DC are also parallel lines. Okay, it's given that segment AE is to segment EB, the ratio is 3 is to 2. So segment AE is to segment EB, the ratio is 3 is to 2. It's also given the segment EG is 6 centimeters. Segment EG is 6 centimeters. Segment BC is 13 centimeters. The question is, find the measure of segment AD. So where's segment AD? This segment. So what will be the measure of segment AD? Okay, if you're going to take a look at the figure, okay, this segment or this straight line is parallel to this line as indicated in this symbol. So these are parallel lines. So it means segment AD is the same measure with segment GF and segment HC. So these are also X. Or let's say this is X. So X, and here, this is also X. Okay, now, when we draw this straight line here or this segment, we now have this triangle and this smaller triangle. These two triangles are similar figures. Okay, the 3 and 2 here refers to the ratio as given in this problem. So, we can find the measure of segment AD, GF, or segment HC using the ratio of similarity. Okay, since these two triangles are similar figures, then this is 3 is to 3 plus 2, 5. So, we have a 3 is to 5. That would be equal to this length, which is 6 centimeters, is to this length. So from B to H. Okay, so from B to H, that would be 13, okay, minus the measure of segment HC, GF, or segment AD, since these three segments have the same length. So minus X. Okay, let's simplify. So this is now 5 times 3 is, 5 times 6 is 30. So 30 is equal to 3 times 13 is 39 minus 3x. Okay, now 3x is equal to 39 minus 30. So it means 3x is equal to 9. So x is equal to 3 centimeters. So segment AD, GF, HC is equal to 3 centimeters. Okay, moving on to our second and last question. According to this, in trapezoid A, B, C, D. So this is our trapezoid. Segment AD is parallel to EF, parallel to segment BC. It's given that segment AE is to segment EB, the ratio is 3 is to 2. So AE, so the ratio is 3 is to 2. Okay, now we will find the measure of segment MN. So it means this segment. Okay, now, this segment MN, as you can see here, okay, first, segment BD is a diagonal line. As you can see, this is vertex and this is vertex, so this is a diagonal line. AC is also a diagonal line. Our focus is to find the length of segment MN. And if you're going to take a look at this one properly, segment MN is actually part of this triangle. Okay, if you're going to take a look at this triangle, this segment EN is the mid segment. Okay, so we are going to find the length of segment EN, and then later on, we will find the length of segment EM, and we are just going to get the difference. So that would be the measure of segment MN. So first, segment EN. So to find the measure of segment EN, okay, let's make use of the given ratio. So this is now 3 is to 3 plus 2. That's going to be 5. So 3 is to 5. Then this is equal to this measure, or to the ratio of this measure. Let's say this is x, is to this length, which is 15. So we have x is to 15. So simplify, this is now 5x is equal to 3 times 15 is 45. So it means x is equal to 9 centimeters. So segment EN is 9 centimeters. Okay, now, as I mentioned a while ago, we are looking for segment MN. So, what we have to do this time is find the measure of segment EM. And later on, we will subtract the measure of segment EM from segment 9 to from segment EN to find the measure of segment MN. So, this segment is part of this triangle. So again, this is 3, 2. So that's the ratio. Okay, this segment is part of this triangle. And these triangles or these two triangles are similar figures. So we can just use the same ratio or the ratio of similarity. Okay, so in here, this is 2 is 2, 2 plus 3, or 5. So we have 2 is to 5. That's going to be equal to this ratio. Okay, let's say this is y. So it's going to be y is to this length, 10. So y is to 10. So this is now 5y, okay, is equal to 2 times 10 is 20. So it means y is equal to 4. So we already found out that segment EM is 4 centimeters. Okay, now to find the measure of segment MN, because from E to N or segment EN, that's 9 centimeters. So to find the measure of segment MN, we just have to subtract 4 from 9. So 9 minus 4, then that means segment MN is 5 centimeters.